This is from the worksheet, solution preparation problems, and just want to go through this second problem right here on how many grams of pure salt are mixed into the solution. In this, we're given 135 grams of sodium acetate, and it's 96.2% pure into 225 milliliters of solution. Calculate the amount of pure wksheet added to the solution. Well, there are a couple of ways to work this problem. One is if you consider the 135 grams as the impure sample, then the pure amount added is 96.2% of the 135. So grams of pure NaOAC is equal to 135 grams times 96.2%, or 96.2% of the 135, which is 135 times 0.962 grams pure NaOAC, and that's 129.87 grams of the NaOAC. And if you wanted to calculate the molarity based on adding that pure amount to 225 mils, you could get the molarity on the definition, moles NaOAC over volume of solution in liters. So that would be 129.87 grams divided by 82.03 grams per mole, and that divided by 0.225 liters, and that will give gives a 7.04 molar solution of sodium acetate. Now the problem can be worked using the formula that I gave you on determining mass of sample needed to make a solution, that is, mass in grams is equal to molarity times volume times formula weight over the purity factor. Now the grams of sample would be the impure sample, because the formula over here takes into account the purity factor against the pure substance, which is mass number would be in the molarity number in here. So what we need to do is convert this or solve this for the molarity, which is your purity factor, times the grams of impure sample divided by the volume of solution in liters times the formula weight of the sodium acetate. And this calculation. Now, molarity is moles over volume in liters, and so we can solve this for moles of pure NaOH, which is now equal to purity factor times grams impure times volume expressed in liters divided by volume of liters again times formula weight of the sodium acetate. Well, volume in liters will cancel out. Now, moles is, of course, mass of the pure sample divided by the formula weight of the sodium acetate, and that's equal to the purity factor times grams of impure sample divided by formula weight again. Like that. So if we multiply both sides by the formula weights will drop out. And we'll have the mass of pure sample that you use to dissolve this, which will be the purity factor times the grams of impure sample, and that in essence is 96.2% of the sodium acetate, so that'd be 0.962 times the grams, 135 grams, and that works out to be the 129 or about 130 grams of pure sodium acetate. So that's just simply using the original formula and solving it and finding the mass number out of the molarity number from the original equation.